Welcome back. Let's continue with 4.3, orbital overlap and hybridization. In this video, we are going to focus how to form the hybrid orbitals, and then we are going to describe the process, and then we are going to show the overlapping diagrams. Let's proceed to the tutorial. Question number 4. For the following molecule, describe the hybridization process, and then we are going to draw the orbital overlapping. So, as usual, when we want to do this description of the hybridization, first we have to draw the Lewis structure. Next, from the Lewis structure, based on the number of electron domain, we are going to identify what is the type of hybridization. Then, generally, we need to write the ground state for the central atom, and then excited state, followed by hybrid state. And lastly, we are going to draw the overlapping diagram. Let's start with question 4b, which doesn't have any non-paired electron. As we know, boron have 3 valence electron, hydrogen have 1 valence electron. So each of them going to form one bond with the boron. So this is the Lewis structure for BH3. After we get the Lewis structure, then we're able to know the type of hybridization is sp2. Then next we are going to draw the orbital diagram for the valence shell of boron. Okay, ground state of boron. Since boron is in period 2, so it will possess 2s and 2p orbital. Ground state is the way that we draw the electron configuration based on the Aufbau principle. So that's why here we have 3 valence electrons. But according to the Lewis structure, we have 3 bonds. Means that we need to have 3 unpaired electrons. But in the ground state here only show 1 unpaired electron. So that's why we will proceed to excited state for boron. So one of the electrons from the 2s will be excited to 2p. So now after excited state, we will fulfill the requirement 3 unpaired electrons. Then we can proceed to hybrid state. So for the hybrid state, based on the type of hybridization here, sp2, means that we are going to mix 1s orbital and 2p orbital. Therefore, here we will label at sp2. At 2p orbital, we still have 1 unhybrid 2p orbital. And each of the sp2 orbital will going to have 1 electron. So with this, we can draw the overlapping diagram for this BH3. As we already know, there is 3 electron domain. So the most accurate or the most suitable arrangement for this boron will be trigonal planar. So we're going to draw trigonal planar first, and then we are going to label each orbital here is sp2 orbital, and this is the orbital for the boron. We write B in the middle. Each orbital has 1 electron. Then the boron is going to hybrid with hydrogen, at where the ground state of hydrogen only have 1 electron, and then 1 orbital in the energy level n equal to 1 only possess 1s. Okay, so now 1s, the shape for the 1s orbital is sphere, so we are going to draw 1s, label 1 electron, and then this is 1s orbital, hydrogen. This is sigma bond, overlap 1 hydrogen, 1s hydrogen, and then this is sigma bond. We have to label. Okay, another one hydrogen atom again, sphere, 1s orbital, hydrogen, we're going to form sigma bond because all the orbital here, they are overlapped head by head. So that's why this is the overlapping diagram for BH3. Okay, now proceed with 4e. This question also, this compound also does not have a lone pair electron. So SeCl₆ have 6 valence electron, chlorine has 7 valence electron, but altogether we have 6 chlorine. So from here total we have 48 valence electron. With the 6 terminal atom, 6 times 8 equal to 48. So means that this compound doesn't have any lone pair electron. So we have 6 terminal atom, means that they are 6 electron domain. Then from this number of electron domain, we know the type of hybridization will be sp3d2, and then the basic shape will be octahedral. Okay, so then we will roughly draw the Lewis structure for the SeCl₆ chloride. Cl, all these 6 are Cl, with each of them have 8 valence electron. So then SeCl₆ is the element in period 4. So we start with the ground state. So we have 4s, 4p, and also 4d orbital. So 6 valence electron, 2 at the 4s, and then follow Hans rule. 1, 2, 3, 4, 5, 6. Okay, so again, from this question, Lewis structure here, we have 6 bonds. So means that altogether, we need to have 6 unpaired electrons. But when we look at the ground state here, only have 2 unpaired electrons, means that we're going to assign the electron from 4s and 4p orbital to 4d orbital. Okay, so one of the electron assigned to 4d from 4s, and another one electron also assigned from 4p to 4d. After we get the 6 unpaired electron, then we can proceed to the hybrid state, which is sp3d, 1, 2, 3, 4, 5, 6, sp3d2, 1, 2, 3, 4, 5, 6, then left 3, 4d orbital is unhybridized. Okay, then next we are going to proceed with the overlapping diagram. So as just now we already know that the base electron arrangement for the orbital is octahedral. So we're going to draw the shape for the octahedral. Okay, so I think this one I need to draw. Okay, so this is the octahedral basically. Before that, try to label all these orbitals first. sp3d2, 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 sp3d2. And then in the middle here, I will label SeCl₆. So each orbital, just now we say that we can see there is 1 unpaired electron for all these 6 orbitals. Then because of SeCl₆ chloride again, form the bond with the chlorine. Chlorine is element in period 3. So 3s, 3p. 1, 2, 3, 4, 5, 6, 7. Means that we know this 3p orbital will going to overlap with the SeCl₆. The shape is dumbbell. So we are going to draw. Okay, 1 dumbbell, chlorine, label 3p. Another 1 dumbbell, chlorine 3p. 1 electron, label sigma. So here I also miss out the sigma. And then here another dumbbell, label chlorine 3p. 1 unpaired electron, sigma. Here another one chlorine, 3p orbital have 1 electron, sigma. Here going to form another sigma bond, chlorine, 3p. Here another 3p orbital, 1 electron, form sigma bond and then chlorine. So basically this is the overlapping diagram for the SeCl₆. Okay, let's continue with 4D. Tellurium has 6 valence electron. Chlorine has 7 times 4. 28 plus 6 total is 34 electron. So because I have 4 terminal atom here, 4 times 8, 32 minus 32 have 2 electron. So as here I know we have 4 terminal atom plus 1 lone pair. So total will become 5 electron domain. And then the type of hybridization will be sp3d. Okay, this is the first one that we already know. Then now we can roughly draw the Lewis structure for the TeCl₄, tellurium chloride. As we know, 5 electron domain means the basic shape is trigonal bipyramidal. With 1 lone pair, it will be looks like a seesaw. So tellurium, Cl, and then so basically this will be the Lewis structure for the tellurium chloride. Okay, so complete with the lone pair electron. Then we know that tellurium is an element in period 5. So we start with the ground state. Okay, so period 5 so consists of 5s and then 3 5p orbital and 5 5d orbital. So because of have 6 valence electrons, so fill up according to the alphabet rule first, fill up in 5s. Once 5s is full, then we'll go to 5p, then we will follow Hans rule. So 1, 2, 3, 4, 5, 6. But when we look at the Lewis structure here, we have 4 bonds. So means that we need to have 4 unpaired electron. However, when we look at the ground state, there is only 2 unpaired electron, means that we have to cross it to a excited state. So the electron from the 5s does not have any changes, but one of the electron from 5p will be going to excited to 5d. One of the electron excited to 5d, it will cause that they have 4 unpaired electrons. So then now we can proceed to hybrid state. As hybrid state is 5 sp3d, so we are going to combine sp3d 5 electron. Then now the unhybridized 5d orbital only left 4 orbitals. So first orbital of the sp3 have 1 lone pair, and then another 4 will consist of unpaired electron. Next, we are going to proceed with the overlapping diagram. So as we already know, just now we say that the basic shape for this compound is trigonal bipyramidal. So we're going to draw the structure of trigonal bipyramidal. It's like a trigonal first, and then with a linear. Okay, so now I will label all these sp3d, 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 sp3d. Okay, so for this one, we'll have 1 lone pair electron, and then others have 4 unpaired electron. Okay, so in the middle here, I will label tellurium. Okay, so this tellurium will going to overlap, form the bond with the chlorine. Okay, so as we know that the ground state orbital diagram for chlorine is in period 3, 3s, 3p, and also consists of 3d. Okay, but because of chlorine, we know that it is halogen have 7 valence electrons, so we will fill up the electron according to Aufbau first, then Hans rule. So we will notice that this orbital will going to overlap with the tellurium. So this orbital is 3p orbital, so that's why the shape will be dumbbell. So I try to use another color to represent. So here we will going to have one dumbbell. So this one you're going to label 3p. In the middle here you label Cl, 1 electron. This bond is considered sigma bond because the orbital is overlap head by head. So here is another 3p orbital. In the middle here we write chlorine, and then 1 electron form sigma bond. Again here have another orbital, p orbital with 1 electron, form sigma bond, chlorine label 3p. And then here also have another 3p orbital which represent the chlorine, so label this as sigma bond. So this will become the overlapping diagram for the tellurium chloride. After trying to draw the overlapping diagram for the compound or the molecule without lone pair electron, with lone pair electron, now we are going to proceed with the molecule or ion with the charge. Okay, so chlorine has 7 valence electron, oxygen has 6 times 4, so total is 31, and then negatively charged means gain 1 electron, so total is 32 electron. Due to have 4 terminal atom, 4 times 8, 32, from here we know that there is no extra electron. So altogether have 4 electron domain, and each electron. So the type of hybridization will be sp3, and then the basic shape is tetrahedron. Okay, next we are going to draw the Lewis structure for the ClO4 negative, chlorine as the central atom, and then we try to draw it in the tetrahedral shape, complete with each terminal atom with the 8 valence electron. So because the compound have charge, so basically we need to calculate the formal charge. Oxygen with 1 single bond, the formal charge is -1, -1, -1, and -1 here. So, and then chlorine have 7 valence electron, 4 bonds, so will be 7 minus 4, we get +3. Total formal charge is -1, which is similar with the charge showing there. Okay, so from here, we're going to start with the ground state of chlorine. So again, chlorine is in period 3, so we will going to show 3s, 3p, and also 3d orbital. Chlorine originally consists of 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. But because of the formal charge that we calculate just now is +3, means that this chlorine going to remove 3 electrons. So we need to have ground state of chlorine 3+. Okay, so when remove 3 electrons, so basically it will going to remove the electron from 3p orbital because this is considered the outermost. So end up we will going to have 2 unpaired electrons from in the 3p orbital. Okay, 3d orbital is still empty. Then now again, based on the Lewis structure here, we have 4 bonds. So generally, we supposedly also need to have 4 unpaired electrons. Then now we need to proceed to a cited state for the Cl3+, means that one of the s orbital one of the electron from s orbital will going to assigned to 3p, while there is no electron assigned to 3d, so 3d orbital will still maintain empty. So after assigned state, we need to proceed with the hybrid state for Cl3+, which is sp3. So 1, 2, 3, 4 with the empty d orbital. So now we are going to proceed with the overlapping diagram. Cl3+ with the shape tetrahedral. So we will label here Cl3+. Each orbital have 1 electron. And then each orbital here we are going to label sp3, sp3, sp3. And here also sp3. So then we need to do the orbital diagram for the ground state for the oxygen. As we know, oxygen in period 2, so only will consist 2s and 2p orbital. Each oxygen has 6 valence electrons, so they are going to have 2 unpaired electrons. But if you still remember just now, we calculate the formal charge for oxygen is O negative, which means the oxygen is going to gain 1 electron. So it will fill up the electron will fill up in 2p orbital, and then now we have 1 2p orbital, which is have one unpaired electron. So this orbital is 2p orbital, which will be going to overlap with the sp3 orbital here. So again, sp3 orbital is the orbital have the dumbbell shape. So we are going to draw dumbbell over here. Oxygen, 1 unpaired electron. Sigma, 2p, another 1 dumbbell over here. Oxygen level 2p, 1 electron, sigma. Here also same, oxygen, 2p orbital, 1 electron, sigma. Over here also the same, 1 electron, sigma oxygen. And here also is the 2p. Okay, then don't forget we need to have a overall charge. Do a big bracket here, which is equal to -3. Now let's proceed with another question with the charge ICl4 negative. Again, iodine 7 valence electron, chlorine also 7 valence electron. Total here is 35 valence electron. But when we look at the positive charge here, we know that they are going to lose 1 electron, 34 electron remaining. But then each chlorine have 7 valence electron, have achieved octet. So 8 times 4, 32 minus 32, we have still another 2 electrons. So 4 terminal atom plus 1 lone pair electron, the electron domain is 5. And then we will have sp3d with the basic shape trigonal bipyramidal. Okay, then now here we will going to draw the Lewis structure. Iodine with Cl, and then with 1 lone pair electron. So basically we know the shape will in the seesaw. And then we need to, because this ion consists of charge, so we need to calculate the formal charge. As we know, the formal charge for the halogen with single bond, the formal charge always equal to 0. So means that for this iodine, 7 minus 6, so we'll have positive 1. So this positive charge belongs to iodine. So again, like just now, we're going to write the ground state for the iodine. Iodine in period 5. So we'll consider of 5s, 5p, and also 5d orbital. Iodine initially have 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. But because of just now we calculate the formal charge, the iodine is I+, means that going to lose 1 electron. So end up they only left 6 electrons. 1, 2, 3, 4, 5, 6. Okay, 5d is still empty. Then based on the equation here, we have 4 bonds. So means that going to have 4 unpaired electrons. But in the ground state here only have 2 unpaired electrons. So we're going to proceed to a cited state for the I+. One of the orbital from the 5p will be going to assign to 5d. So that now I+ consists of 4 unpaired electrons. Then now we can proceed with the hybrid state for the I+, at where we are going to mix s orbital and sp and d orbital, 1 pair, 4 unpaired electrons, and then with 4 unhybridized and empty 5d orbital. Okay, then we are going to draw the shape for the ICl₄ plus with a shape of trigonal bipyramidal. So we try to draw a trigonal planar first, and then followed by a linear shape. So this is iodine, sp3d, 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 and this one also sp3d. Okay, then now you can put plus over here because just now we already identified is I+. So each orbital here have 1 unpaired electron, but then only 4, 1 have 1 lone pair electron. You can refer to the hybrid state orbital diagram. Okay, then Cl again is Cl, so that's why we already have the idea lah. 3s orbital and then 3p as 1 unpaired electron. So this unpaired electron electron in the 3p orbital will going to overlap with the I+. So overlap 1 electrons sigma chlorine level 3p. Over here same case happen, chlorine 3p 1 single electron sigma. Over here also the same, 1 electron 3p chlorine. Okay. Sorry. Dumbbell shape, 1 electron sigma chlorine 3p. So for this one, you no need to put the charge is overall charge is okay because you already highlight the positive ion over here. So this is the overlapping diagram for ICl₄ positive. Okay, we will continue to discuss another tutorial question in next video. So generally in this video, we try to learn about how to describe the hybridization process and also draw the overlapping diagram for the compound or the molecule without lone pair electron, with lone pair electron, and also with the charge. So see you in next video. Thank you.